You finally did it. You picked your tiny home design. You cleared your land. Maybe you even watched 100 videos right here on YouTube about which layout to choose and what builder to hire. But here's the question almost nobody in the tiny home world talks about. And it's the one question that will determine whether your tiny home is still standing strong in 20 years or slowly falling apart from the ground up. How well is it anchored? Not the walls, not the roof, not the loft. The connection between your tiny home and whatever it's sitting on. That single detail, foundation anchoring and final setup, is the most skipped, most misunderstood, and most costly phase of any tiny home build. And today, on Tiny Home Reveal, we are going all the way in on it. I'm going to show you exactly how anchoring works for every type of tiny home setup, walk you through the step-by-step process pros use, show you the mistakes that are wrecking tiny homes across the country right now in 2026, and give you the final setup checklist that your builder should be completing before you ever move a single piece of furniture inside. Stay until the end, because the final setup sequence is where most tiny home builds quietly cut corners, and I'm naming every single one of them. If tiny home builds, reveals, and real behind-the-scenes construction knowledge are what you're here for, you are on the right channel. Hit subscribe right now so you never miss a tiny home reveal drop. We do this every week. Okay, let's get into the foundation. Here's the first thing you need to understand. Tiny homes face unique anchoring challenges that standard residential construction guides don't fully address. And that gap in information is costing tiny home owners big money. A traditional stick-built house sits on a full perimeter foundation with significant dead weight holding it down. It's heavy. That weight alone provides a measure of resistance against wind, uplift, and lateral movement. Your tiny home, by comparison, is light. Whether it's on a trailer, on piers, or on a compact concrete slab, it has a fraction of the mass of a conventional home. That means forces that a conventional house would shrug off. A strong wind event, shifting soil, frost heave, flood surge, hit your tiny home with far greater relative intensity. The foundation must transmit both dead loads, the weight of the structure itself, and live loads, which include equipment, occupants, and environmental forces like wind and snow, into the earth. When your structure is 200 square feet instead of 2,000, the anchoring system carries a proportionally greater responsibility. And in 2026, this is becoming more urgent. Suppliers and builders within manufactured housing are now making industry professionals aware of a new vertical anchoring system for factory-built home foundations, aiming to strengthen stability and safety in high-wind areas. The industry is waking up to the fact that light structures in high-wind zones need anchoring systems that go well beyond the minimum. So the first rule of tiny home foundation anchoring is this: don't assume standard residential guidelines are enough. Tiny homes need purpose-built anchoring thinking. And that's exactly what we're covering today. Before we talk hardware and installation, let's identify which category your tiny home falls into. Because the right anchoring strategy depends entirely on your foundation type. There are 4 main setups in the tiny home world, and each one has a completely different anchoring approach. Setup Type 1. Tiny home on a trailer, THOW. This is the most popular tiny home setup in 2026, and the one with the most anchoring mistakes happening right now. A tiny home on wheels, THOW, sits on a steel trailer frame, which means your first anchoring challenge isn't concrete. It's the connection between your home's structure and the trailer itself. The house must be through-bolted to the steel trailer frame at multiple points, not just lag-screwed to the deck. Floor framing should integrate hurricane ties or Simpson strong tie connectors at the trailer-to-structure interface. This is a detail that budget builders skip constantly. They'll use lag screws into the trailer deck and call it done. That is not enough. Through bolts, multiple points. This is non-negotiable. Look for trailers rated at 10,000 to 14,000 pounds GVWR, gross vehicle weight rating, with dual axles and electric brakes. Frame construction should include welded steel crossmembers every 16 to 24 inches to support floor joists without sagging. And when the trailer is parked, the home needs to be anchored to the ground as well. Ground anchors, helical earth screws driven into the soil, connect to the trailer frame via straps or chains. This keeps the whole unit from becoming airborne or drifting during a high wind event. If you're parking your THOW semi-permanently, This step is as important as the trailer-to-home connection above it. Setup Type 2. Tiny home on piers. Pier foundations are extremely popular for permanent tiny home placement, especially in rural settings where pouring a full concrete slab isn't practical or permitted. The home sits on a series of concrete blocks or adjustable steel piers, and the entire anchoring system works through those pier-to-ground anchor connections. Often employed methods include using tie-downs, piers, and concrete foundations, each strategically chosen based on local soil conditions and anticipated environmental stresses. For pier setups, ground anchors are driven into the soil beside or beneath the piers, and steel straps run from the frame of the home down through the pier system and into those anchors. The strap tension is what holds the home against uplift. This system works well in good soil conditions, but requires soil testing, because in soft, sandy, or expansive clay soils, standard pier and strap systems can fail dramatically. The critical final setup step on a pier foundation. Every pier must be load-bearing and level. Even one pier that's short, soft, or settling will cause differential movement, where one corner of your tiny home drops while the others stay put. That shows up as sticking doors, cracked drywall, and eventually structural damage to your frame. Setup Type 3. Tiny home on a concrete slab. This is the most permanent tiny home foundation, and the one that most closely mirrors conventional residential construction. New construction using cast-in-place J-bolts set into the foundation before the pour requires half an inch minimum diameter, 7-inch embedment, spacing no more than 6 feet apart, and a bolt within 12 inches of every plate end, per IRC or 403.1.6. For a tiny home footprint, this often means fewer total bolts than a full-size home. But the spacing and placement rules don't change just because the structure is smaller. In fact, they matter more, because each bolt is carrying a greater share of the load relative to the structure's size. The slab itself needs to be engineered for the tiny home's specific load. A tiny home on a concrete slab should have rebar reinforcement, proper thickness for the load, and a vapor barrier underneath to prevent moisture migration up through the slab. Setup Type 4. Tiny home on a crawl space or perimeter foundation. Less common in the tiny home world, but growing fast as zoning codes evolve, especially for ADUs and backyard tiny homes in urban areas. Crawl space foundations elevate the structure slightly above ground level, creating a small space between the ground and the first floor. This type provides easier access to plumbing and electrical systems and offers better protection against moisture than slab foundations. For tiny homes on a crawl space, the anchoring system runs from the sill plate at the top of the foundation wall, down through the crawl space framing, and into the ground anchors or footer below. In seismic regions, shear panels on the crawl space cripple walls are mandatory, and for tiny homes in earthquake country, this step should never, ever be skipped. Let's talk hardware. This is where the YouTube tiny home content usually goes vague. Make sure it's anchored properly, without ever explaining what properly actually looks like. Here's the real breakdown. J-bolts and L-bolts. New slab construction. These are your cast-in-place anchors. They go into the wet concrete before it cures, with a bent hook, end buried inside the slab and the threaded end sticking up above the surface. Cast-in-place J-bolts and L-bolts are the common choice for new foundation construction. Their bent ends create mechanical resistance within the concrete, helping secure sill plates and structural framing. For a tiny home slab, you'll typically be setting these bolts yourself if you're owner building, which means timing is everything. Go too early, the bolt sinks as you place it. Go too late, the concrete is already stiffening and the bolt won't seat properly. The sweet spot is when the concrete is consolidated and leveled but still workable, usually 20 to 45 minutes after the pour, depending on weather and mix design. Epoxy anchors. Retrofitting into existing concrete. Bought a property with an existing slab that wasn't prepped for a tiny home? Epoxy anchoring is your answer. A hole is drilled into the cured slab, cleaned thoroughly. And this cleaning step matters enormously. A dirty hole means a failed bond. Then structural epoxy is injected and a threaded rod is set into the wet epoxy. When cured, the bond can exceed the tensile strength of the surrounding concrete itself. Wedge, sleeve, and expansion anchors are also used when attaching materials to existing concrete. After a hole is drilled, The anchor expands against the sides of the concrete to create a secure hold. These are faster to install than epoxy, but generally have lower pull-out values. So in high wind or seismic applications, epoxy is the preferred retrofit method. Ground anchors and earth screws. For THOW and pier setups, your primary anchoring hardware is the ground anchor. Either a driven steel stake with a loop head, or a helical earth screw that's literally screwed into the ground using a power head. Helical anchors are a great option when working with rugged terrain or poor quality surfaces. The helical screw design displaces soil as it goes and rather than removing it, which actually increases the holding capacity compared to driven stake anchors in many soil types. Rated working loads for helical ground anchors typically range from 3,000 to 6,000 pounds in medium soil conditions. For a tiny home in a high wind zone, you want anchors rated conservatively. Use the higher end of the load rating, not the minimum. Simpson Strong Tie and Structural Connectors. If you haven't heard of Simpson Strong Tie on this channel before, remember the name. They are the gold standard for structural connection hardware in residential construction, including tiny homes. Foundation anchors provide a direct connection between the foundation and the framing of a building to resist uplift and lateral forces. Simpson makes a full range of products specifically designed for this. Mudsill anchors, foundation plate connectors, joisted foundation ties, all engineered, tested, and code listed. The wood side of these connectors takes standard SDS screws, and the anchorage side takes 5/8" anchors. Installation is fast and easy with no through bolts required on newer connector designs. They're G90 galvanized for corrosion resistance, and HDG or black powder coat is available. For a tiny home near the coast or in a wet climate, galvanized or stainless hardware is not optional. It's essential. Now let's walk through the actual installation process, phase by phase, for the most common tiny home setup. A slab foundation with a wood frame tiny home. The principles apply across other setup types, adapted for your specific situation. Step 1. Pre-pour preparation. Preparation begins well before the concrete truck arrives. Have anchor bolts, templates, layout measurements, washers, nuts, and any required reinforcement ready for installation. Verify bolt counts, dimensions, and spacing requirements before work begins so materials are available and installation can proceed without interruption. For your tiny home footprint, lay out the full sill plate position on the ground before the pour using chalk lines or batter boards. Mark every bolt location on that layout. Build a simple template from scrap lumber. Drill holes at your bolt spacing, so you can drop all bolts into the wet concrete simultaneously at the exact right positions. Step 2. Reinforcement placement. 4 concrete slabs, 6x6 welded wire mesh or number 3 rebar grid at 18 inches on center, suspended in the middle of the slab with chairs, provides tensile reinforcement. Clear cover should be 3 inches for concrete cast against earth and 2 inches for formed surfaces exposed to weather. If possible, wire the anchor bolts directly to the rebar before the pour. This keeps them locked in position as the concrete is placed and vibrated. A bolt that drifts during the pour can end up misaligned with the sill plate, which means either drilling it out or using an oversized plate hole, both of which compromise performance. Step 3. The pour and bolt setting. This is real-time work. As concrete fills the forms, have someone dedicated solely to bolt placement. Not pouring, not screeding, just bolts. Use your template to maintain spacing. Set each bolt to exactly 7 inches of embedment. Mark your bolts with tape or a marker beforehand, so you're not guessing depth in a hurry. After bolts are set, check plumb on every one before the concrete gets too stiff to adjust. A bolt that's leaning even slightly will make sill plate installation harder and reduce the effective pull-out strength. Step 4. Curing. The most skipped step in tiny home builds. Concrete doesn't dry. It cures through a chemical process that takes time and proper conditions. One of the most damaging mistakes is rushing construction by removing forms too early, allowing the foundation to dry out too quickly, or building on the foundation before it reaches adequate strength. Concrete reaches only about 70% of its full strength in the first week and continues gaining strength for months. Concrete typically cures for 7 days before light construction begins. On a tiny home build timeline, this can feel like an eternity, especially if you're owner building on a tight schedule. Resist the urge to rush. A foundation poured on a Monday should not have a wall frame going up on Wednesday. Let the chemistry work. In hot or dry conditions, which many tiny home builds happen in, since people often build in warm months, keep the slab moist with wet burlap, plastic sheeting, or a spray-on curing compound. Rapid moisture loss during curing can reduce final strength by 50% or more. Half strength on the one component your entire tiny home depends on. Step 5. Sill plate installation. Now the satisfying part. The sill plate, pressure-treated lumber, goes down over the anchor bolts. Always use PT lumber here. The sill plate is in direct contact with concrete, which holds moisture, and standard dimensional lumber will rot at that interface. For a tiny home, that rot can go unnoticed for years until it becomes a serious structural problem. Place a sill seal gasket between the concrete and the plate. This is a foam or a rubber strip that acts as a thermal break, an air barrier, and a moisture barrier all in one. Drill the plate to slip over the anchor bolts. Set it down, add your washers and nuts, level the plate carefully, and torque the nuts to specification. Double-check measurements and confirm corners are square using the 3-4-5 triangle method. If one leg measures 3 feet, the other 4 feet, and the diagonal is exactly 5 feet, your corner is perfectly square. Out-of-square sill plates become out-of-square walls, and out-of-square walls become a tiny home that never feels quite right. Step 6. Hold downs and shear connections. In seismic zones, all shear walls must be mechanically fastened to the foundation with metal hold downs, metal straps, closed-space anchor bolts, or some combination of these. Even outside seismic zones, hold downs at the corners of your tiny home structure significantly improve wind uplift resistance. Simpson Strong Tie makes hold down hardware specifically sized for small footprint structures. Use it. This is the section I promised you at the top. The final setup checklist that separates a tiny home that's truly ready from one that just looks ready. Walk through every one of these before you move in, before you sign off on the build, and before you make your final payment to any contractor. Checkpoint 1. Inspect every anchor point. Walk the perimeter. Check every bolt head, every nut, every washer. Loose or corroded anchor bolts can compromise the integrity of the frame, leading to structural misalignment. On a THOW, check every through-bolt connection between the home frame and the trailer. Pull on the straps if you have ground anchors. Nothing should move. Checkpoint 2. Level check. Plate and floor. Get your level out. Check the sill plate at multiple points around the perimeter. The tolerance is tight. Plumb and level within 1/8 inch and 10 feet. For pier-supported tiny homes, check the floor deck for level and look for any pier that's settled, shifted, or carrying uneven load. A settling pier will show up early as a slightly bouncy floor. Catch it now before it gets worse. Checkpoint 3. Drainage and moisture. Check for moisture accumulation around the foundation, as excessive water can lead to erosion over time. Grade the soil around your slab or piers so water runs away from the structure, not toward it. If your tiny home is on a trailer, check that the trailer frame isn't resting in a low spot that collects water. Steel corrodes. PT lumber resists moisture but isn't waterproof. Long-term water contact at the foundation level is the beginning of the end for any tiny home. Checkpoint 4. Verify permit and inspection sign-off. Check local building codes for permit requirements. Many jurisdictions have specific guidelines for foundation construction, including depth, reinforcement, and anchoring techniques. Before you occupy your tiny home, and before you make a final payment to any builder, confirm that the foundation phase has been inspected and signed off by your local building official. If your builder is telling you permits aren't necessary, that's a red flag worth investigating before you move in. Checkpoint 5. High wind and storm readiness. For tiny homes specifically, this is non-negotiable. In coastal and high wind zones, foundation anchors must resist hurricane force uplift. Use embedded straps or bolts with higher uplift ratings than standard residential specifications require. For those in wind-prone regions, the ground anchor system should be rated for your local design wind speed, which you can find in your local building code or ASC 7 wind maps. Don't guess on this. Calculate it or hire a structural engineer to verify your setup. The cost of that consultation is nothing compared to the cost of watching your tiny home roll over in a storm. Checkpoint 6. Load path continuity. This is the one that separates a truly engineered tiny home from one that was just assembled. Don't spend the time putting in a bunch of anchor bolts if you don't have hold-down paths above to make those bolts useful. The structure must be nicely fastened together from foundation to roof, so the structural system is continuous. On your tiny home reveal walkthrough, whether it's your own build or one you're considering, ask specifically, what is the hold-down path from roof to foundation? If nobody can answer that question clearly, you have a problem. Let me be completely straight with you, because that's what this channel is about. These are the real mistakes happening in the tiny home world right now, in 2026. And knowing them in advance is the difference between a tiny home reveal you're proud of and one that becomes an expensive regret. Mistake 1. Lag screwing instead of through bolting on a THOW. We touched on this earlier, but it deserves emphasis. Lag screws into a trailer deck do not provide the same uplift resistance as through bolts with backing plates on both faces of the trailer steel. If your THOW builder used lag screws and called it anchored, push back. Ask for the through bolt connection detail. Mistake 2. No soil investigation before choosing a foundation system. Variable ground conditions, vibration limits, and restricted access all increase the likelihood of performance issues if foundation systems are not engineered for the actual site conditions. The land your tiny home sits on has a soil-bearing capacity, a measurable number that tells you how much load the ground can support per square foot. If that number is low, soft clay, loose fill, or organic soil, a standard pier system may not perform as designed. Mistake 3. Rushing the cure to hit a move-in date. One of the most damaging mistakes is building on the foundation before it reaches adequate strength. The move-in date is exciting. We get it. This is tiny home reveal. We love the reveal moment. But a reveal that happens a week too early on a foundation that hasn't fully cured is a reveal that will eventually look very different in all the wrong ways. Mistake 4. Ignoring the spacing rule at plate ends. The bolt within 12 inches of every plate end rule, as required by IRC R403.1.6, gets skipped constantly. On a tiny home perimeter, you may have 4 or 6 plate sections with joints between them. Every single joint needs a nearby bolt. Check this on your build. Check it on any build you're considering buying. Mistake 5. Skipping the sill seal. It's a $30 roll of foam gasket. It seals the air gap between your concrete and your sill plate, which on a tiny home represents a much larger percentage of the total building envelope than on a conventional home. Skipping the sill seal on a tiny home means cold floors, energy loss, and moisture intrusion right where you can least afford it. Mistake 6. Not accounting for long-term pier settlement. When a foundation is actively settling unevenly, contractors must install steel or helical piers to anchor the structure to stable soil or bedrock. Industry data shows the cost per pier ranges from roughly $1,000 to $3,000, with a typical installation requiring 5 to 10 piers, bringing total cost to $5,000 to $30,000. That's the repair cost when pier settlement goes ignored. Inspect your piers annually. Level your tiny home if you notice any change in floor feel, door operation, or wall alignment. Foundation anchoring and final setup is not the part of your tiny home that shows up in the reveal video. Nobody's gasping at the anchor bolts. Nobody's sharing photos of the sill plate installation on Instagram. But here's the truth that every tiny home owner needs to hear. If this phase isn't done right, none of the rest of it matters. The kitchen, the loft, the clever storage, the beautiful finishes, they're all sitting on top of this one invisible phase. Do it right. Know what to ask. Know what to inspect. And never let anyone rush you through it. Drop a comment below. I want to know, what type of foundation setup is your tiny home on? Or what are you planning? Slab? Trailer? Piers? Let's talk about it in the comments. I read everyone. If this video helped you, hit the like button. It genuinely helps this channel grow and helps more tiny home dreamers find content that tells them the truth. Subscribe to Tiny Home Reveal if you haven't already, and check out our next video right here, where we pull back the curtain on tiny home shell builds and what your builder should be doing before the walls ever go up. This is Tiny Home Reveal. We show you everything. See you in the next one.